Hi all, this is Mr. Yeager for chemistry, and we are now looking at physical and chemical properties and changes. Again, these are things we have talked about before throughout the year, but we're going to try to just give a little bit more focus with them during this unit. Again, because we are looking at matter as a whole and looking at the things that are around us and that we can interact with, and so we want to be able to describe them very clearly. This is another excellent presentation made by another chemistry teacher. And here we go. All right, so what's a physical property? A physical property is basically some sort of characteristic, like it says, that is not associated with the change in its chemical composition. Duh. Okay. What that really means is, it's the way I like to say what a physical property is it's anything that we can associate with one of our 5 senses. So touch, smell, taste, see. I mean, even hear. Obviously, there are things that you can, you hear the noise and you're like, oh, I know what that is. So that would be a physical property of that object, all right? And it's also anything that basically could be generally measured in a lab, okay? So mass, you can see examples down there, density, temperature, if you take physics, speed, acceleration, those would be all the physical properties of that substance that it has. Obviously, they can change based on what you do with messing around with them. We'll get to that. But that is a physical property. We do mention that they can be intensive or extensive. We don't need to get too much into that. What intensive physical property means is this is a property that never changes based on the size of the object. Extensive is something that will change based on the size of the object, okay? So a lot of these down here that are listed, these are intensive properties. The density of a substance always stays the same regardless of what size you have. The color should stay the same. The hardness, the melting and boiling points should all stay the same. An extensive property would be something like the temperature of it. What is the temperature at that time? What is the mass of it at that time? Those are examples of extensive properties. A chemical property is a property that describes how that substance will change when it undergoes some sort of reaction, or how it reacts with other things. So the key things with chemical properties is to go, is this describing some sort of reaction that it will have? So anything that involves fire is a chemical property of it, because fire requires it to react with oxygen. So flammability and combustibility, those are 2 words that basically mean how well it catches on fire or how well it explodes based on fire. Poisonous, so toxicity, okay, is another example. Something, because toxicity means how it will react and possibly create a poisonous negative reaction with you. Anything with reactivity, acidity, those are chemical properties. So again, people do struggle with these. I will say the majority of our examples will be physical properties, okay? Because if it's not dealing with any sort of actual reaction, okay, to change into something new, it's a physical property. If it's something I am observing, okay, sensing and so forth about it, again, focusing on color and hardness and smell, those are physical properties. Chemical properties describe how it would change, okay? Changes, okay, obviously now we get to it. Physical change is where we actually change the appearance, but we don't change what it is. I don't think we have a lot to say with that. We do not change what it is. We change its appearance, but we don't change what it is. Now, the 2 on here that people mess up every single time and call chemical changes: melting, condensing, okay, boiling, any sort of phase change is a chemical change. Sorry, physical change, okay? Any sort of phase change is a physical change. Go with pH, okay? A phase change is a physical change, because if I boil water, it's becoming H2. It's going from H2O liquid to H2O gas. I'm changing its appearance, but it's still water. So a physical change, a phase change, is a physical change. That's really, really important. The other one students mess up with commonly is when you dissolve something. When you dissolve something, it is just going into the mixture. You're creating a mixture, and we said mixtures are physical reactions, physical changes occurring, not chemical. So those are the ones I would hope you don't mess up on. I think obviously ripping and cutting and breaking and things like that, people understand those are physical. If I color something or paint something, that would be a physical change because it's still what it is. Remember phase change and dissolving as physical changes. A chemical change is anything where you actually have a chemical reaction. A chemical change is chemical reactions. All right? So if a chemical reaction is occurring, a chemical change is happening. All right? We obviously have changes in physical properties during that because you're creating something new, but we have to clearly understand we are making something new. So once again, if fire is involved and you're burning it or baking it or cooking it, that is a chemical change that is happening. All right? If you're just warming something up, that's not a chemical change, that's a physical change. But if you are I'll say physically, sorry. If you are burning, cooking, baking that object, that is a chemical change. And then you have other ones there. Rusting, tarnishing. Tarnishing is just another word for rusting. Digesting and rotting, that is all chemical changes, okay, that are occurring. As I say with digesting, the food does not come back out the same way it went in usually, okay? So it's definitely changed. So we do need to kind of point this out. We've covered this before back in the chemical reaction unit. Signs of a chemical change, you can see all those. Changing in color is a common one. Change in temperature without any sort of heating or cooling device. Odor change, that's a very common one in your house. You could sit there and be like, man, what's that smell? I know something's not right. It's because some sort of chemical reaction is occurring that you might not want. Formation of a gas and production of a precipitate. Those are all examples of chemical changes. All right. So now that we have that, we are also going to look at, these are all separation techniques, and we're going to practice some of these in a lab as well, separation techniques. So we are now looking at, you have a mixture, and we're going to separate them out. So this is going to be a physical change because you're changing the appearance by separating those two things out from each other. All right? One of the first forms of a separation technique would be evaporation. Evaporation is where we have a solution. So think of salt water. We're going to use salt water. Well, I think this is the best example of salt water. We have salt water, and you let that water evaporate over time. All right? The red particles in here are supposed to represent the salt. The yellow is the water. Over time, the water should evaporate out. You can even use this as an example. If you're at the beach, you jump in the water, the ocean water, the salt water, and you come out and you don't dry yourself off. The water will evaporate off your body, but the salt will remain. That's why you sometimes feel maybe a little bit kind of sticky from that salt, okay? But the salt will remain at the bottom. So that's one technique. We are separating the two substances because they have not chemically reacted, and you're left with one substance at the end. Hand sorting is pretty clear. All right, that would just be the idea that I'm sure you've had, when you think about when you were younger and you had to put away your toys, all right? You had to separate everything out. Hopefully you didn't just toss everything back into one giant bin, okay? But you had to separate which toys go where, everything like that. I mean, that would be like cleaning your room, okay? So that's hand sorting things. Filtration. This is where, as you probably can recognize, you use a piece of filter paper. This is used to separate out suspensions, okay? Because the particles are large enough to be blocked by the filter paper. The smaller particles, like the liquid water or liquids, would pass through, okay? If you like coffee, obviously you use filtration to make coffee because you don't want all the grounds in your cup of coffee afterwards. Another one, chromatography. Maybe you did this back in middle school, okay? Chromatography is a neat one, okay? This is where you are separating out a solution, okay? We can use this to separate out inks and different pigments, okay? We primarily practice this usually in the example to your left is basically there are different color markers and you place it into a solution. We actually call it a chromatography solution. It's like an alcohol-based solution. And what happens is that solution, you mark your paper with what we call, that's the paper's what's called your stationary phase because the paper's not moving. And you mark it with your little inks, and then the alcohol is your mobile phase, and it will slowly seep up the paper. It will dissolve that mixture of inks, and then it's interesting where certain inks can be held longer than others as the mobile phase gets thinner and thinner and thinner, and that's how you can separate out the colors. We do similar techniques actually for crime scene investigations, you know, I mean, even with, I'm not going to even, like, even with blood in a way, there's techniques to kind of separate out those parts to try to identify different things. If you've ever heard of electrophoresis, it fuses, I mean, that's another separation technique that we get very technical with. It sort of looks like chromatography, but it's where you're separating DNAs based on charges and so forth. Distillation. Distillation. This is used also to separate a solution, and you're using the fact that the two liquids have different boiling points. And so you heat up the solution, and what you'll run into is the liquid with the lower boiling point will actually, you'll see the whole thing start bubbling, but it's interesting because it's only that substance that has the lower boiling point that's bubbling, and it will rise on up, and then there's a little cooling, like there's the thermometer at the top, and it's cooler at the top, so the liquid will condense, but then it's kind of led down this tube to help condense it, okay? So that, and if it doesn't condense, it's still, like, the gas runs down this tube, there's water running along it to cool it off, and it'll condense and you'll separate it on out, which is pretty neat. And then we have decanting. This is where we use usually a stir rod, but where we try to separate a suspended liquid mixture, so you like oil and water, and we try to separate off them by layers, because obviously as you pour, that top layer should go off first. But this one we get a little more specific with, where we use a little stir rod to help guide it, because obviously we don't want to pour really fast, we only want small amounts to come out, and we do not want the lower layer to come in. This one is usually very difficult to completely do because there's always going to be probably a little bit of a layer left over at the top. And that's it. So we looked at physical and chemical changes and properties, be able to identify those, and we're going to, you'd be separating out the physical chemical properties in a separate section, physical chemical changes, and then understand these different separation methods and when to use them. That's the main thing. All right, thank you.